Imagine waking up to a message from the universe that breaks the rules of physics we have trusted for more than a century. That is exactly what scientists around the world faced on March 12, 2026. Just 8 hours before the first internal report circulated, NASA's Deep Space Network and the European Space Agency's Gaia mission confirmed a measurement so unlikely that its statistical probability is only 0.001%. In scientific terms, that number is almost impossible. Normally, something that rare would immediately be blamed on faulty equipment, software glitches, or calibration errors. But this time, every system that could verify the reading was checked again and again, and the result remained exactly the same. Across NASA's tracking network, atomic clocks are now being compared in real time with telemetry arriving from deep space. These clocks are among the most precise instruments humanity has ever built. Their accuracy is so extreme that even a difference of a billionth of a second can be detected. Yet, despite this precision, something strange is happening near an object known as 3I Atlas. According to the measurements, time around this object is running 2 full minutes slower than time on Earth. And even more disturbing, that difference is growing larger with every passing hour. To understand why a 120-second gap in time is not a small error, but a massive rupture in our understanding of physics, we have to go back to the theory that first explained how time itself can change. In 1915, Albert Einstein published the field equations of general relativity. His insight was revolutionary. He realized that mass and energy do not simply exist inside space. They shape it. In fact, they curve the geometry of space-time itself, the four-dimensional structure where every event in the universe takes place. When a massive object sits in this cosmic fabric, it creates a kind of depression, a distortion that affects everything nearby. Objects moving close to it follow curved paths, and even time itself begins to flow differently. The stronger the gravitational field, the slower time moves. This effect is called gravitational time dilation, and it is not just theoretical speculation, it is something we measure constantly. For example, the GPS satellites orbiting Earth cannot function without corrections based on Einstein's equations. Because those satellites are farther from Earth's gravity, time for them moves slightly faster than it does on the ground. If scientists ignored that difference, navigation systems would become useless within minutes. Every time you open a map on your phone and follow directions somewhere, you are benefiting from the fact that time itself stretches and compresses depending on gravity. Normally, these effects are extremely small. Earth's gravity only changes the flow of time by tiny fractions. But around more extreme objects, the difference becomes much larger. Neutron stars, for example, compress more mass than the Sun into a sphere only about 20 kilometers wide. On their surfaces, time runs significantly slower than it does far away in space. And if you move even closer to a black hole, the effect becomes almost unimaginable. Near a stellar mass black hole, the distortion of space-time becomes so extreme that time slows dramatically compared to distant observers. At the event horizon, the boundary beyond which nothing can escape, time appears to freeze completely. To an observer far away, clocks near that boundary would seem to stop. That is the level of gravitational influence required to produce large changes in the flow of time, which is exactly why the numbers connected to 3I Atlas are so troubling. According to standard general relativity, creating a 2-minute time difference detectable across interplanetary distances would require a gravitational source with a mass comparable to tens of millions of suns. That is roughly the mass of the supermassive black holes found at the centers of small galaxies. Yet the region where this distortion is appearing contains nothing remotely that massive. The first sign of trouble actually appeared weeks earlier. On January 14th, engineers at the Goldstone Deep Space Communications Complex in California sent out a routine radar pulse toward the object now known as 3I Atlas. At that time, the object was located about 2.1 astronomical units away from Earth. Based on the known distance, the radar signal should have taken exactly 34 minutes and 12 seconds to travel to the object and return. Instead, the signal came back slightly late. The delay was tiny, just 0.04 of a second. Under normal circumstances, that difference could easily be explained by atmospheric interference or minor calibration drift. The Goldstone team reset their timing systems, double-checked their atmospheric correction models, and repeated the measurement 2 days later on January 16th. This time the delay had grown to 0.18 of a second. That might still sound small, but the change itself was the alarming part. The delay was increasing, and the pattern of that increase suggested exponential growth rather than random error. Within 48 hours, the anomaly had multiplied more than 4 times. Quietly, without making a public announcement, NASA alerted the European Space Agency. ESA responded by redirecting one of the most precise space observatories ever built, the Gaia spacecraft. Gaia normally maps the positions of stars across our galaxy with extraordinary accuracy. Its measurements can detect positional changes smaller than a microarc second, which is equivalent to measuring the width of a human hair from thousands of kilometers away. On February 2nd, Gaia locked its instruments onto the region surrounding 3I Atlas. What it found confirmed that something far stranger than a simple radar delay was happening. The positions of background stars located directly behind the object appeared slightly shifted from their catalog coordinates. Their light was bending as it passed near the region. This phenomenon is called gravitational lensing, and it was first confirmed in 1919 during a solar eclipse when Arthur Eddington measured the bending of starlight around the sundial. The effect occurs when a massive object warps space-time strongly enough to deflect light passing nearby. But here was the impossible part. The object producing this lensing effect was estimated to be only about 5 kilometers wide and had the density of loose snow. Faced with evidence that space-time itself was bending around something so small, scientists searched for a hidden source of mass that might explain the distortion. The Atacama Large Millimeter Array in Chile, known as ALMA, redirected its 66 antennas toward the same region of space. ALMA specializes in detecting faint radio signals from extremely cold or invisible cosmic objects. If a dense body, such as a neutron star, a black hole, or even an unusual concentration of dark matter was hiding near 3I Atlas, ALMA should have seen it. But ALMA found absolutely nothing. The region appeared to be a near-perfect vacuum, no dense companion star, no dark matter cluster, no invisible object capable of producing the enormous gravitational curvature that Gaia was measuring. Yet 3 completely different systems, using 3 different measurement techniques, had now confirmed the same thing. Goldstone radar timing showed signals slowing down, Gaia's optical instruments showed light bending, and ALMA's radio observations showed empty space where the mass should have been. All 3 pointed toward a conclusion that should not exist. Space-time was curving around an object that did not appear to have the mass required to bend it. By March 1st, the time delay measured from radar signals had increased to 30 seconds. Over the next 11 days, the number exploded. On March 12th, the difference reached 120 seconds. The pattern was unmistakable. The effect was not stabilizing. It was accelerating. A region roughly 10,000 kilometers across surrounding 3I Atlas was now operating on a different clock than the rest of the solar system. Then another piece of evidence appeared. Spectroscopic measurements from the Kike Observatory detected a subtle shift in the wavelength of light coming from opposite sides of the object. The leading edge showed a slight blue shift, while the trailing edge showed an identical red shift. That combination of signals suggested something extraordinary. Space itself appeared to be contracting in front of the object and expanding behind it. If that interpretation was correct, the distortion matched a theoretical structure first proposed in 1994 by physicist Miguel Alcubierre. His equations described a hypothetical warp bubble, a region of space-time where space contracts ahead of a craft and expands behind it, allowing faster-than-light travel without violating relativity. For decades, the Alcubierre metric remained purely theoretical because the energy requirements seemed impossible. Maintaining such a warp bubble would require negative energy densities far beyond anything humanity could generate. Yet the data surrounding 3I Atlas looked exactly like the signature of such a field. But there was something even more unsettling hidden inside the measurements. Every 14 minutes and 23 seconds, the time dilation surrounding the object surged. The baseline delay of 120 seconds suddenly spiked to 125 seconds. The spike lasted exactly 3 seconds before returning to normal. And during those 3 seconds, something strange happened to the stars behind the object. They disappeared. During those brief 3-second spikes, the gravitational distortion around 3I Atlas intensified so dramatically that the light from background stars vanished entirely. Their light was not scattered or dimmed. It was bent completely around the distortion field and never reached Earth. For a moment every 14 minutes, the object produced a perfect ring of darkness, a circular region where no photons arrived at all. It behaved like a temporary event horizon, blinking on and off with mechanical precision. Natural cosmic phenomena simply do not operate on schedules like that. Pulsars spin in milliseconds, neutron stars pulse rapidly, and variable stars brighten and dim over periods of days or weeks. But a cycle repeating every 14 minutes and 23 seconds is something different. That interval fits perfectly within the time scales engineers use when designing machines that must charge, discharge, and regulate heat in a repeating sequence. In other words, the pattern looked less like a natural astrophysical event and more like a system operating on a controlled duty cycle. The precision of the timing made the situation even stranger. Every cycle occurred at exactly the same interval, with variations so small they were below the detection threshold of atomic clock comparisons. Such stability suggested a timing source as accurate as the most advanced clocks humans have ever built. Theoretical models of the Alcubierre warp drive provide a possible explanation for what that cycle might represent. To maintain a warp bubble, an enormous amount of energy must continuously sustain the unusual geometry of space-time around the craft. The negative energy density needed to expand space behind the bubble and compress it in front must be constantly replenished. If the energy supply drops even briefly, the geometry collapses and the warp bubble disappears. The 14-minute pulse pattern fits the behavior of a system that charges to peak energy density, sustains the warp field, then briefly reduces output to manage heat or recharge its power storage before beginning the next cycle. It looks almost like breathing, an engine with a heartbeat. But that raises an even bigger problem. The amount of energy required to sustain such a structure cannot come from any ordinary natural process. Even a modest warp bubble, roughly 10,000 kilometers wide, would require energy on a scale equivalent to converting planetary masses directly into power. Einstein's famous equation describing mass-energy equivalence shows just how enormous that requirement is. E equals mc2. This relationship tells us that even a tiny amount of mass contains enormous energy. Yet the energy needed for the field surrounding 3I Atlas would still exceed what any chemical reaction, nuclear process, or conventional electromagnetic system could produce naturally. There is only one theoretical energy source that could explain such power without a visible fuel supply: zero-point energy. Quantum physics tells us that empty space is not truly empty. Virtual particle pairs constantly appear and vanish due to the uncertainty principle. This activity means the vacuum itself contains measurable energy. If a civilization had learned how to extract and control that energy, the entire universe would effectively become their fuel source. And the measurements from 3I Atlas suggest exactly that might be happening. And if that interpretation is right, then what happened next becomes even harder to dismiss as a strange but natural anomaly. At 1800 UTC, on March 11th, the shape of the time dilation field changed. Until then, the influence region around 3I Atlas had appeared mostly spherical, spreading outward in every direction. But the latest measurements showed it stretching along the object's line of travel, forming an elongated ellipsoid aligned exactly with its velocity vector. At almost the same moment, Jet Propulsion Laboratory tracking data confirmed that the object had increased its speed by 1.2 kilometers per second. There was no exhaust plume, no propellant trail, no thermal signature, and no evidence of expelled material of any kind. Under ordinary physics, that should be impossible. Newton's third law tells us that every acceleration requires a reaction. Push something forward, and something else must be pushed back. But in this case, the instruments recorded acceleration without any visible reaction mass. The simplest explanation was also the most disturbing one. 3I Atlas was not pushing against gas, dust, or fuel. It was pushing against space-time itself, turning an engineered distortion in geometry into forward motion. That is what reactionless propulsion would look like if it were not violating momentum, but exchanging it with the metric of space-time rather than with expelled mass. Then the situation changed from extraordinary to unmistakably deliberate. At 2245 UTC on March 11th, the Deep Space Network station at Canberra received a narrowband transmission from inside the time dilation bubble at 1420 MHz, the hydrogen line. That frequency is not random. For decades, it has been one of the most important frequencies in the search for extraterrestrial intelligence because hydrogen is the most abundant element in the universe, and its spectral line is considered a natural reference point any advanced civilization would know. But the content of the signal was even more revealing than the frequency. It was structured, digital, and compressed by a factor of exactly 120, perfectly reversing the known time dilation ratio so that a signal sent from inside the bubble would arrive on Earth at a normal clock rate. That means whoever transmitted it knew the time distortion precisely, calculated the correction, encoded the inversion, and deliberately matched the communication to our frame of reference. When scientists at JPL decompressed the message, they did not find a greeting, a sequence of prime numbers, or some abstract mathematical constant. They found the original Goldstone radar ping from January 14th returned back to Earth verbatim, with one critical change. The timestamp in the metadata had been corrected to account for the time dilation field. In plain language, the message said something astonishing without using words. We know your clock is wrong. We know by exactly how much. Here is the correct time. That is not the behavior of a rock. It is not the behavior of a random natural phenomenon. It is not even the behavior of an automated system repeating a stored program without understanding. It is the behavior of something that received our signal, understood it, modeled its own relativistic field with precision, and chose to answer in the language of physics itself. And that answer was not just a reply, it was a lesson. If that message was a lesson, then the deeper question is no longer whether intelligence is involved. The question is what kind of intelligence teaches before it introduces itself. Because a teacher implies a student, and that single choice tells us more than any greeting ever could. Whatever is inside that bubble did not speak to us as equals. It responded one level above us, carefully calibrated, so the message would be understandable, but still clearly beyond our own present capability. Not so advanced that we could not decode it, and not simple enough to suggest parity, exactly one step ahead. That is the signature of an intelligence that may have done this before, one that knows how to make first contact with a civilization advanced enough to understand the mathematics, but not yet advanced enough to build the physics for itself. Seen through that lens, the rest of the evidence begins to connect into one terrifyingly coherent picture. In theoretical frameworks like string theory, the hidden extra dimensions of the universe are not just abstract mathematics. They are part of the deeper structure through which forces, particles, and energy interact. In that view, negative energy states are not impossible violations of reality, but consequences of a geometry we do not yet know how to manipulate. A civilization that can engineer that geometry would not experience interstellar distance the way we do. It would not see distance as a wall. It would see it as a variable, something adjustable, compressible, and navigable through the deeper architecture of spacetime. That would make the 14-minute cycle the heartbeat of a machine operating on principles far beyond our engineering. The zero-point vacuum would become its fuel. The 10,000-kilometer time dilation sphere would become its moving shell, and the corrected timestamp would become its calling card, left not by accident, but by decision. Because a civilization capable of all this does not casually broadcast on the hydrogen line with exactly the correction needed for its own relativistic distortion unless it knows someone is listening, knows someone has been listening for decades, and knows that someone will understand the meaning of what was sent back. Now connect every point. The delay grew from 0.04 seconds on January 14th to 120 seconds by March 12th, not as random drift, but as the steady spin-up of a warp field moving toward full power. Gaia confirmed gravitational lensing without detectable mass because the curvature may be generated by structured negative energy rather than matter. KEK recorded the exact blue shift and red shift pattern predicted for a warp bubble. JPL measured acceleration without exhaust, implying propulsion through engineered space-time geometry. And then came the corrected return signal, not just proof of intelligence, but proof of intent. Now, consider the timeline. The field expanded from 30 seconds on March 1st to 120 seconds on March 12th in just 11 days. If that exponential pattern continues, the distortion could reach the inner solar system within weeks. That leaves only two real possibilities. Either 3I Atlas is preparing for a faster-than-light departure, building toward a final surge before vanishing, or it is preparing to enclose something at a specific target distance. Something it has already observed for 45 consecutive days. Something whose radar ping it has already returned. Something called Earth. We have the clocks. We have the transmitters. We have the math. What we do not know is whether we have the courage to answer. If this possibility fascinates you, subscribe, like the video, and tell me in the comments what message humanity should send back before the deadline runs out.